Okay, we're starting with a homework question from the fraction turn-in section of Mad Science. The last one, this terribly confusing one, put there just to make everyone hate me. And a key to this problem is that we have the word of. So what math does of turn into? What arithmetic operation?
Well, it's either probably division or subtraction.
Yeah. In this case, actually, it's multiplication. It could be many things. You are right to not be a fanatic and say that of always means multiply. Because
It does? Really?
No, it doesn't.
Oh.
But some people are taught that of always means multiply. And in this case, it does. But I just want to do a heads up. Of does not always means multiply. So
But sometimes it does.
Sometimes it does. It often does. In real life, it sort of
Really?
most often does, but not 100% of the time.
Oh.
So if we want to think about that, let's do that on another slide. So of means multiply. So if I have like 4 of those, then you're picturing that I'm making copies of it. I'm not sure what those are, but whatever it is, there's times 4, right? Or if I have half of that, then I'm not sure what that is, but whatever it is, it's a times 1/2. Or divided by 2 if you're like thinking about that. But if I'm keeping focus on what's on the page, it's a times 1/2. So it's this kind of where we're saying we're making copies. We're having 4 of those or only half a copy of that. Does that make sense so far?
Yeah, that probably like cleared up a lot of my struggle because the answers that I were coming up with weren't anywhere near on your page for possible answers.
So what this problem does on purpose is give you fractions, because this isn't so bad with this no fractions. If I say you have 30 cents every day and 4 of those days go by, how much money do you have? You would do 4 times 30 cents and not have any trouble with it. If I throw in one fraction, then it might mess up your brain a little, even though the math is exactly the same, just because fractions make us hesitant and we don't do what we would do if it was a whole number. If I toss in 2 fractions, then for some reason it really seems harder to know what to do, even though it's still just the same as you earned 30 cents a day for 4 days. Of is meaning multiply for exactly the same reason. So let's go back to this problem. So she has a 7/8 pound silver bullion bar, and she left 2/3 of it to Lloyd. So Lloyd gets 2/3 of 7/8. If I want to, I could just multiply straight across here. If I want to not have the number 16 show up on the page, I could divide by 2 with canceling. And so Lloyd gets 7/12 of this bar. We're not done, but are you okay with that one step? And if this doesn't seem the same as saying that somebody earned 30 cents for 4 days, and so that they should have $1.20, then kind of stare at it a little, because it's just the same thing. We're making copies. We have 2/3 of a copy of something. The something happens to be a fraction, but it's still of means multiply for the same conceptual reasons. Okay, then Lloyd gave each of his children a quarter. So they get a quarter of that. It's again an of multiply. So we're going to take the 7/2 and we're going to say, what's a quarter of that? And if it helps, maybe I'm actually writing this in the wrong order. Maybe you would like it where the 1/4 comes first, because this is like how many pieces, how many copies of the original amount. That's sort of the the order I've been doing things so far, how many copies of an amount. So they get a quarter of the original amount. There's no canceling that can happen here. We just multiply straight across the top and across the bottom. And we're done. Is 7/48 one of the answers? Let's check. Yep, there it is.
So then I guess my biggest problem was the fact of the word of, because I was trying to divide it and trying to, or subtract it. Like I worked on this problem for a long time with division and subtraction, trying to get an answer that you had there. And finally I just guessed and turned my assignment in because I didn't realize of meant multiply. So
we'll talk about that more later.
It makes a lot more sense.
This problem is there on purpose to show you that think about of meaning multiply if you're not used to that, but also don't trust it too much because we're going to see both things happen in the future of Math 20.
So a little foreshadowing.
Yes.
Okay.
It's sort of like someone snuck up and hit you on the back of a head in dark alley for the purpose of foreshadowing. Slightly impolite, but now you know what's coming.
Okay. All right. Thank you. I appreciate your time going over that because, yeah, it definitely had me going last night. So.
Okay. Don't spend too much time on any one problem. No
okay.
one problem is worth it. That's why you can email or text me or wait till class or something.
Okay. All right. Thank you.
Okay. You're welcome. Speaking of homework help, even though I love to see your smiling faces, we did have an attempt to do something with the Math Resource Center on Saturday. And that went okay, but not great. Only one person showed up. 4 people said that they wanted to come, but only one did. And I understand that Saturday at 1 has a high likelihood of being the kind of time slot that sounds great in theory, but actually something else winds up happening then when it comes around. But the Math Resource Center wants to do more stuff. So if you are wanting more tutoring, then either work with them or work with me to work with them. We're exploring, should they do other things if making appointments isn't right? Maybe the study session should be a different time of day. Maybe we should make it where you can email them questions and then they will make a little YouTube video and send you the answer, and then I can put it in the YouTube channel and you would get the direct link, or so on. We're not quite sure how to have the tutors at the Math Resource Center the most helpful for people. So if you have ideas about that, either put them in chat just now or let me know on an email or something like that, and I will try and get them as helpful to you as possible. Okay, other announcement, looking at the syllabus, rounding and fraction format and percent format and measurement are all due. If you haven't turned in measurement because you were waiting for this problem to be done in class today, then get it done by the end of the day. And we don't have any due dates for the new things. And our first topic of mad science, the fractions, we just had a question about because, so that won't have a due date yet. Maybe in 2 classes, but not yet because Chrissy just asked about that. Okay, other homework questions or other questions before we move on to new material? Can I repeat what I said? Sure. So if I go back to come on. Here we go. Rounding, fraction format, percent format, and measurement, and the shape shifting all have due dates. So, whoops, not that one, this one. So here we go, rounding, fraction format, percent format, and measurement. Measurement isn't due until today, so finish it up if you haven't yet, and then nothing will be late. We also have those reflections. If you haven't done those, do the 2 reflections. If you're looking for those reflections, they are not on the turn in homework page from here, turn in stuff. Instead, The reflections, you find them either by going to playgrounds and going down just a little bit and there's reflections, or we're far enough along in the term that your achievements will start becoming a to-do list. If you go to the homework, then you could get to the reflections there, as well as any turn-in homework page that you wanted. So the achievements almost become like your landing site as the term goes on. Oh, here's where I turn things in. Anyway, for mad science, things are due the class after no one has questions about them. So since we just did have a question about fractions, then we don't have a due date for that yet. If there were no questions about fractions, it would be due next class, but that has not yet happened yet. And that makes sense because we haven't even finished it, right? We're still on mixed number subtraction as far as our progress through things. Okay. Other questions before we get started? Thanks. So I guess that's where we are. We've done the basic arithmetic with fractions, adding, subtracting, multiplying, and dividing. For mixed numbers, there's a little subtlety. This is something that if you are very happy with what we've done the last two classes, you can just sort of tune it out because who cares? But for some people, this makes a lot of sense based on your background. And when we have mixed number subtraction, there's two ways to do it. We could say, let's make everything an improper fraction. Improper fractions are usually the best way to deal with these types of things. And let's just do that. But we can also think of it like place value. So that's this method here. So let's do two different problems both ways. Make this not so wide. Better for my copy. Okay. So we start with a problem where we have a 3.5 inch board. And I want to cut off 2.25 inches. How much is left? Not a very practical situation, but it's a math class. We're just doing this because the numbers are nice. I can say, well, 1/2, I can unreduce that. Is 2/4. Then I can say 2/4 minus 1/4 is just 1/4. 3 minus 2 is 1, and get a nice answer. Other people will say, no, that's not how my brain likes it. I'm going to do, the same exact problem, but I like improper fractions. So I'm going to have 3.5 minus 2.25, and say 3 times 2 is 6, plus 1 is 7. 2 times 4 is 8, plus 1 is 9. I can't do halves minus quarters unless they have a common denominator. Now, did I actually get the same thing? Is 5/4 the same as 1 1/4? Sure, right? If I'm drawing my picture, then 5/4, 1 1/4. There we go. 4 and 1 more is fine. So some people like this. Part of the reason people who like this like it is because you do wind up with a mixed number. If you're doing carpentry or baking or things, then that's nice. Other people like this one, and often they like it because it winds up with an improper fraction. And if you were doing some sort of algebra or computer programming, that's probably what you want. In Math 20, I have no preference. I don't know what your future is, if it involves carpentry or baking or physics or algebra or computer programming. So if you want to write something as a mixed number or an improper fraction, both are great for the answers. But learn one of these two methods. Are you going to turn things into improper fractions and then do your arithmetic? Or are you going to treat the fractional amount like a place value? It does get a little more complicated, but before that, I want to make sure there's no questions on the 2 slides I just did.
And tell me again what you called this one that's up.
This one is borrowing like place value. It is not really true that this is a place value, right? It's not tens or tenths or anything like that, but we're pretending it's a place value. Okay, I'm going to move on because people, I think, are done. Holler if I'm moving too fast. Now we have a different problem. We have a 5 1/4 inch board, and I want to cut off 3.5 inches. I can do the same thing, say we need a common denominator. So let's change this 1/2 into 2/4. But now I'm kind of stuck and want to do 1/4 and take away 2/4. So that's not going to work. I don't have enough quarters to take away the 2 of them. So I need to do something else. What should I do?
Take 4/4 from the 5, make it a 4.
So we're still thinking like place value. We're borrowing just like we would if we were elementary school students learning how to subtract with actual place value. I'm going to take the 5 and make it a 4. That gives us 4 more quarters. So now I have 5 quarters because 5 became 4 plus 4 quarters. Everyone okay with my borrowing? So if I have 5 quarters, I take away 2. Now there's 3 of them. 4 minus 3 is 1. And there we go. Other people don't like that. They are the improper fraction brain people. So I will get questions about that in just a moment, but first let's finish it the other way so those people don't have to wait impatiently. Five times 4 is 20, plus 1 is 21. 3 times 2 is 6, plus 1 is 7. As before, this answer puts out an improper fraction, but 7/4 is the same as 1 3/4, so they match. Okay, I'm going to let this crowd have its slide a little longer to be fair, but questions about any of these four things? Oh, all good. Okay, so this is obviously put into Math 20 for the culinary subjects. Right? People doing stuff with kitchen math do a lot of this kind of thing compared to people going into algebra. So, okay, small subtopic. That's the mixed number part. Now the part that everyone cares about. So, okay, I'm gonna mute Debbie for a moment. I hear background noise. Okay, order and terms. And I also see her question in chat, by the way, but I'm waiting on purpose for that. So let me make this a little bigger, actually. Too big. If you are in the textbook, that's free. We're on page 73. If you're in the green book with zebras, we're in section 4.4. Hugely important thing, but mostly just so that you leave Math 20 without making mistakes that embarrass you. We're actually not going to have too many problems like this on the test. So, but we will have some. You have probably heard of PEMDAS, or Please Excuse My Dear Aunt Sally, or something like that. If you haven't, that's fine. If I could see everyone in class, I would say raise your hand if you've seen PEMDAS, but since a bunch of you are not showing me your webcam, then I'm not going to bother with that. So PEMDAS can be useful. It can be helpful if it was taught well, but part of Math 20, as you've seen before, with how to think about division and other things, is to go through all the stuff that someone might not have taught you through no fault of your own and make sure you see it the right way. So it's our turn to do that with PEMDAS. So just as a check, then if I want to do 8 divided by 4 times 2, should I say, let's do the 4 times 2 first, because M comes above D. So we have 8 divided by 8, which is 1. Or if I'm doing 8 divided by 4 times 2, do I do the 8 divided by 4 first because of some left to right sense? So then I would get 2 times 2 and I get 4. Which of these answers is right? If you like the top one, then either wave in the Zoom or use your thumbs up thing in the Zoom or something like that. So who likes the top one? And if you like the bottom one, then either wave in Zoom or use your thumbs up thing in Zoom or something. So the right answer is the bottom one. If you got it wrong, that's probably not you, that's just whoever taught you this. That multiplication and division have the same priority. If all that's left is multiplication and division, we go from left to right. And similarly, addition and subtraction have the same priority. If that's all that you have left, you would go from left to right. There's a little bit more to talk about what could be done wrong with PEMDAS. So here's what I just said. First, fraction bars are left out, but fraction bars are actually the same as parentheses. Anything somebody writes with a fraction bar, I could rewrite it with parentheses because fraction bars just mean do division. We've already seen in going from fraction to percent format, top divided by bottom changes a fraction to a decimal. So fraction bars, division, there we go. So if we really wanted PEMDAS to be fixed, it would look something like this box. with the P and F is one step, exponents is another step, multiplication and division is another step, and lastly, addition and subtraction is another step. And when things are within the same step, you go left to right. But that's incredibly awkward. No one ever writes PEMDAS this way on their scrap paper. We might mentally organize it this way in our head, but this is just kind of bulky. So there's a better way to deal with this kind of thing. And that better way is terms. And at this point, lots of things just changed in my Math 20 audience in a normal class. A bunch of people that were sort of saying, okay, I've done PEMDAS, this all makes sense, are now like, terms? Terms are brand new. What are terms? So if that is you, that is okay. That's how most Math 20 students are at this moment in the lecture. So terms is a way to prioritize things correctly when doing these long problems. So we need a definition. A term is a portion of an expression separated from the equal sign only by addition or subtraction. So I'm going to grab that and I'm going to put it on not just one, but 3 different Jamboards. Okay. So that didn't make much sense when I just read it to you. Let's actually look at one. Actually, I'm going to grab things while my window is narrow. Okay, now I will write on them. So in this expression, I'm going to start, and I get to a plus or a minus that's not inside parentheses. So this is one term. And then I keep going, and I get to my equal sign. So that's its second term. We'll solve this later, but for now we're just counting the terms. Let me do another one before I ask for questions. So, aha, I come to a plus or a minus that's not inside parentheses, so that's my first term. There we go, that's a second term. I come to a plus or minus that's not in parentheses. And there's a third one. You can see that not all terms are equally exciting. This term is only the number 5. That's okay. Okay. One more, then I'll ask for questions. Your turn, though. How big is the first term as I'm working my way across this expression?
Just the 11?
Just the 11. Right? As soon as I get to this plus, that's the end of my first term. Okay, somebody else. When does my next term stop?
8 times 2.
8 times 2. Okay, third term.
Divided by 7.
After the 7, yeah. The fourth term goes all the way to that minus sign. This one is inside parentheses, so And then we have a fifth term here. Okay, so at this point, you don't know why we care, but any questions about these three slides, about how to break up one of these long expressions into terms? Everyone's happy. Okay. So why we care about these is the terms are completely independent until we finally put them together at the end. So let's show you what that's like. Here's the same three problems we just did. And we're going to partly use what we talked about with PEMDAS, but we're also going to use this terms idea to make things easier. So this problem had two terms, and that plus is just going to kind of wait around. And these two terms are independent. It doesn't matter which one I work on first until we actually add them at the end. They don't care about each other. So 4 times 2, or 4 plus 2, I'm sorry, is 6. 6 divided by 3 is 2. 2 times itself is 4. 8 times 4 is 32. And then 2 plus 32 is 34. Questions about that one? Christina's looking very skeptical. Why is he doing this to me? It's only Monday. Okay, at this point, we really weren't doing anything special. We were doing just PEMDAS. We did some parentheses first, some exponents. Then we did some multiplying and dividing, and then we added things. But it helped keep us organized. When we get to the next one, then we're going to be increasingly thankful that we have terms. So we had that and that. So 3 different terms. And this minus is going to just continue waiting for its turn to happen. So with this step, we had 1/2 times 4 times 5. It's all multiplying. So we go left to right. Half of 4 is 2. 2 times 5 is 10. With the second term, 9 minus 1 is 8. And 2 times itself is 4. Here we have only multiplying and dividing, so we can go left to right. 3 times 8 is 24. 24 divided by 4 is 6. And this one is just 5. So the 5 sort of comes down, the 10 comes down. 10 minus 6 is 4, plus 5 is 9. Is it beginning to make sense now of why it's nice to have 3 things that don't really care about each other until the very end when we add and subtract? Okay, the next one will be your turn to chime in and help me. So questions about this one or that one before we move on?
No, it makes sense to me.
Okay, I can't quite tell who's writing and who's not on Zoom. I think we're ready to move on. Holler if I'm moving too fast. Okay, so several people chime in. We had terms happening here, 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 and there. Oops. I'm drawing it wrong. Okay, everyone happy with my setup? So this one, I get to go first. Oh, that's just 11. Somebody call out what happens here.
16.
16. Not sure we actually need this many lines. We'll see. Okay, someone else.
2.
Okay, let's make this one 2 steps.
15 divided by 3 is 5.
Okay, and this one, yeah, we don't need this bottom stuff. Okay, last term. 3 squared.
9.
9. 90 divided by 9 is 10. And then finally we go across. We have 11 plus 16, so 25. No, 27. I'm awake. 27. Minus 2 is 25. Plus 5 is 30. Minus 10 is 20. Did I do my mental math right? Okay, why do we care about this? Because lots of things in real life have different portions that contribute together. And we'll have the different terms because they're sort of each coming from a different source. Maybe there's some medical formula and this is about someone's height, and this is about someone's weight, and this is about someone's age, or something like that. So we see terms a lot. So it is good to be aware of terms and to understand why they are powerful. It would be very hard to do this problem without terms. Yeah, PEMDAS is nice, but kind of where do I start? But it's also true that you could just plug all of this in your calculator, and the calculator understands order of operations. So getting to 20 isn't really the point. The calculator could have done that for us already. Okay, we will see terms later on when we do geometry towards the end of things. Questions about any of that? Okay, I'm going to stop the record or pause the record. As a last comment about terms, remember that we can cancel factors of a single fraction multiplication thing, but we can't cancel within terms. So no canceling here. It's not fraction multiplication. Okay, now I'm going to do something that is not in the textbook, but I've noticed teaching Math 20 before that this is a good thing to do, even though it will soon become obsolete. If you remember when we talked about measurement at the very end of shapeshifting, then we had the history part, and then we had the one-step conversions. And I warned you that these rules about multiply this case, divide this case are helpful, but we will get something better. I had to show you this thing about one-step measurement conversions because otherwise the people that are good at this, because they've done lots of baking and carpentry and things, will bug me and say later on, why are you showing us this long process? I can just multiply or divide. Because these rules are things that are just intuitive to them. They've done it so much. So if I skip over this, someone complains. But if you're not good at this, this doesn't turn out to be the best way to do these problems. There's a more reliable and fool-safe thing we will get to later. So we are now doing the same thing with rates. We're going to talk about goes with chains, and this is something that will soon be obsolete. But I can't skip this, or the people that spend a lot of time thinking about rates in real life already are going to nag me and say, there's an easier way to do this, you know. And yes, for them it is easier, but not for everyone. So follow along. Don't worry too much about this. As we've seen, that's not in the turn-in homework, but I have to do this so that the things we do later make more sense. Okay, with that big caveat, you know the 4 basic arithmetic operations, plus, minus, times, and divided. There's another one that you may have never seen before. Officially, it's called the proportional operator, but I'm going to call it the goes with operator, because that's what everyone says when they actually do this. And there is a 3-step process of how to do this kind of problem. I'm going to grab that and put it on a page. Here's the problem that goes with it. Okay, first we're going to list out a bunch of rates. We're using the goes with operator because there's things we do with rates that we don't do with a single number. For single numbers, even if it's a fraction, we tend to just do the normal arithmetic. We add and subtract and multiply and divide. But with rates, we're going to put them together in a new way. Second, we write out our goal and we identify where we start. Just like when we did the King Henry stuff with the decimal scoots for metric measurement conversions, we had to know where we're starting and where we're ending up. And this is a similar thing. And then lastly, we're going to make a chain to link things together to get from our start to our end. And we probably will have to either unreduce or reduce some of our rates to make this happen. Okay, oops, I forgot to grab the actual problem. That might be too big. Okay, shrink you a little bit. Let's cram those over there. Okay, so as an example, Lucy drove from Eugene to LA. On average, she drove 7 hours a day. We just were told that that's the first of our rates. She drives 7 hours a day. She drives 60 miles an hour. Okay. Gasoline costs on average $3 a gallon. Okay. And she has an old car that only gets 20 miles a gallon for her mileage. The question is, how much did she spend each day on gas? So we know we're going to use these 4 rates. It's just not immediately obvious how we smash them together. Everyone okay with my setup? So we listed the rates. That was step one. Step two, we write our goal. And so our goal is dollars. Where are we starting in this question? What's the thing that's not dollars? That's kind of a focus point of this question. Debbie said something, but she's
7
muted.
hours a day.
A day, yeah. So we're going to start with a day and try and get to dollars. Okay, let's see how it works. So we have 1 day. And 1 day goes with 7 hours. It's the only rate here that has a day in it. So I have to use that one. And you only use each of these once. So once we've used it, we can cross it out. Now I want to keep going. 7 hours goes with what? Can I get from hours to the dollars I want? No, this one is the only one with hours in it. It also has 1 hour. So I need to fix that. Make this a times 7 top and bottom. So 7 oops, not hours, miles. So 7 hours goes with 420 miles. I don't think that looks nice. I'm going to do that. Oh, okay. Can I squeeze it in above? Maybe that's better. Okay, so we've used that one. Can I get from miles to the dollars I want? Where's miles? There's miles. No, miles gets me to gallons. What do I need to multiply by to get from 20 to 420? I'll give away my answer. Okay. So 420 miles goes with 21 gallons. And now I can finally get from gallons to dollars. That was my goal. $21 gallons will go with $63. I am hoping this is sensible, but really awkward. Because then I can say, great, it makes sense to you, but there is a less awkward way of doing this that we will learn later on. Questions about this slide before we try one more and then say good enough? No questions. Okay, let's do one more. you do things. So this one is all spelled out for you there. Okay. So we have 6 friends, they want to order pizza. Each person has 4 slices. A pizza has 12 slices, and one pizza costs $14. We're obviously going to do lots of multiplying and dividing. This is when we could just sort of flounder around until we got a good answer. But let's see how this chain helps us know when to multiply and when to divide so we don't mess up. So we've written our bunch of rates. Where are we trying to start and get to?
How much money it's gonna cost, but also how many pizzas we need for the 6 people.
So the goal is our dollars, and the start is the people. Okay, so the only one of these that has people is this one. We're not starting with one person, we're starting with 6 friends. So what do I write next and why?
Would you multiply by 4?
Almost. What am I multiplying by here?
Well, multiply by 6.
I multiply by 6, right? So we're getting 24 slices. Okay, we've used that one. For 24 slices, there's only one of these that has slices. What am I going to multiply by?
Two?
2. I'm looking for 24 slices. A 2 will do that. So 24 slices will be 2 pizzas. That's used up that one. Okay, last time, 2 pizzas. What am I going to multiply for this one?
2?
2, because I want it to be 2 pizzas. So 2 times 14 will be $28. And again, if your brain is now thinking, this kind of makes sense, but this is not how I would do it, that's fine. We will learn a better way to do this. Notice that in all these chains, you can pair up any items you want. Yes, 6 people went with $28. That was sort of our whole problem. But it's also true that 6 people went with 2 pizzas, or 24 slices goes with $28, or 2 pizzas goes, right? You can pick any 2 of them and they match. Similarly here, one day is 7 hours, but it's also true that one day goes with 420 miles, or 7 hours goes with $63, or so on. Any 2 of them fit together.
Would it still make the answer the same?
would it still make the answer the same? I'm not sure what you're asking. Can you rephrase that, please?
How do you write the answer? Is it just how you wrote it, or does it need to be in a
Yep.
certain order?
No, just she spent $63 every day.
Okay.
We're just trying to make a dollar amount that matched with one day, or in this case, 6 friends goes with how much money. So on the website, I've given you more of these. If this is something that your brain feels like you're almost about to get to some plateau and be happy with this, there's some nice simple ones that don't have too many rates going on at once. So stop if you want, or do a few more if it helps you. And if this whole idea of these are rates and we're doing something with them that's not the kind of thing we do with plain numbers, we'll get to this again later with a better way of doing it when we have more math tools. But that's sort of the point of this now, that we can smoosh rates together in some way that we don't smush oranges or elephants or dollars usually. It has to have rates. And that's the end of fraction format. Any questions about that at all before we move on to the next thing? You want to try a 3-minute multiplication thing just to see how it works, or do you want me to have a nice handout with lines on it first?
No, let's try one.
Let's try one. Okay, I'm gonna grab some dice and just roll up some random numbers. So if you have graph paper, that might make this easier. If not, just try it on scratch paper. If you want to like show off and hold it up to the webcam when we're done, then you can show off that you're fast with this, or just keep it to yourself, whatever. I'm going to put 2 different problems on the board. It's a 3-minute quiz because for most people, if you can do a 5-digit times a 5-digit in 3 minutes, then you're in great shape. There's nothing in Math 60 or 65 with reducing fractions or playing with algebra that's going to be hard for you. So on this side, I'm going to do a 4-digit times a 4-digit. And if you're thinking this is just 3 minutes of pain, then go ahead and start in a smaller one. If you are pretty good with your times tables, then go ahead and try a 5-digit times a 5-digit and see if you can finish that. And when you do, tell me and we'll get a star. Okay, so if I roll my dice, I'm getting, oh, that's 3 5s. That will be very repetitive. Let's not do that. There's for that. And if you want to do a harder one, next time I'll get some 10-sided dice so we can have numbers bigger than 6. Okay, work on keeping things lined up, and I will, do I have a 3-minute timer? beep, beep. Okay, stop. There we go. Thank you, phone. I haven't written out long division in quite a while. I had much more trouble keeping things lined up straight than doing that. Tables. Okay, I'm going to stop the share. Anyone wants to hold up their work to their webcam, put a thumbs up or whatever, feel free to celebrate. Okay, so if you got that, got a 5x5 done, then let me know in chat privately or email or something, and I'll mark you off after class. Grab the screen again. Okay, so expressions again were these long bunches of numbers all smashed together, and we've learned what happens when there's fractions in them. So our next step is percents. And we are already at this wonderful place. Thank you again, Chrissy, for your segue to start class with, that the word of is telling us to multiply in many cases. So making copies is what multiplication does. If I'm visiting a candy store and I say I want 10 of those, then I'm saying I want 10 copies of one of those. So when we are having whole numbers, this makes a lot of sense to us. Tickets to an amusement park cost $25. A family buys 5 of them. We know we're supposed to multiply. Or for number 48, if it takes 7 minutes to grade one test and there's 30 students, how long would it take to grade all the tests? We can tell we're supposed to multiply. The way the English language works, it makes sense to also put of in front of a fractional thing. A sports program has 350 students. 3/7 of them are boys. How many are boys? We would take 3/7 and multiply it by the 350. Rihanna eats 5/8 of a pizza. Then her daughter eats half of what's left. How much of the whole pizza did she eat? She would eat 1/2 of not the 5/8, but the 3/8 that were left, and so on. The other occasion when the English language naturally uses of to mean multiplying is when we say percent of. Like, what is 40% of 200? So let's put that in a box. The percent of algorithm says if we're finding the percent of an amount, then we can use RippleUp to turn the percent into a decimal, and then we can multiply. So what is 60% of 200? We still have to RippleUp just because we're writing it with the word percent. Doesn't mean there's not a percent symbol there. So left out of percent, we get 0.6 times 200. So that's going to be a 12 with 2 zeros, and then we back up 1 and get to 120. 40% of 50, so 0.4 times 50. 4 times 5 is 20. We're going to put another 0 on and then back up that 1, so we get. And finally, 10% of 50%. We keep this percent as a label. just like the label for this one was hours, the label for this one will be percent. So we'll have 0.1 times 50% will be 5. Questions about any of those three? No questions. Okay. Now it doesn't matter what order we multiply things. So that means there's a switcheroo trick. And this isn't terribly useful in algebra, but it's a great way to impress your friends. If I'm multiplying a number that's in percent format by a normal number that's not, I'm allowed to switch which one is in percent. All it is a times 1 over 100, right? That's what percent means. And I can do that in any order I want. So if I am saying what is 24% of 25, I don't want to write it as simply 0.24 times 25. That's not a friendly thing. But I can switcheroo it and say, what is 24 times 25%? Put the percent on the other number, and then say, 25% of something is just a quarter of it. That's just divided by 4. And my friends think I'm good at math because I know a trick. Similarly, if I have what is 8% of 900, I don't want to write it. Let's take 900 and multiply it by 0.08. That seems harder to me to do in my head, but I can switch it and say, what is 900% of 8? Put the percent on the other number, and 900% is just 9 times something. So not the most important thing, but keep it in the back of your head maybe. I think there's a homework problem to help stick it in your head. And
You can do that anytime for any.
Anytime you are multiplying, you can switch which number has the percent.
Okay.
When you're multiplying a number in percent format by a normal number, you can switch which one is the percent. And that again is because percent just means times 1 over 100. And I can do that in any order when I'm multiplying three things. Okay, here's something that's more practical. When you're tipping, then you often would tip either 10 or 15 or 20% of a value. So then let's figure out how to do that quickly. To find 10% of a value, I can just scoot the decimal point once to the left. Right? We know that 1/10 of something is one scoot to the left. You've done lots of decimal point scoots. How would I find 20%? Well, I could do one scoot to the left, and that would get me 10%, and then I double it. Because twice 10% will be 20% of something. Similarly, if I want 5% of a value, first I get the 10%, and then I take half of that, since 5 is half of 10. And it does take more than one step, but a traditional tip for average service is 15%. So you do the 10% trick, you would do the 5% trick, and then put those together, since 10 and 5 turn out to be 15. Ready for some examples? So I think this is too much to try and put on the same page with something, but maybe we can fit one. Okay, so 10% is just a scoot to the left. So I would take my $25, do one scoot, and get $2.50. If I want a 20% tip, I would just do that twice and have $5. Maybe I'm writing wrong. Should I write a times 2 here? Looks better. I see some nods. Oh, okay. Next one. So $20, one decimal point scoot left, gives me $2 for a 10% tip. Half of that would be $1 for a half for a 5%. And then if I take those two and put them together, then I would take this one and put them together. And I get 3. Questions about impressing your friends at restaurants? Should we do the last one also? Another example. Oh, we're done with that Jamboard. Okay. Okay, your turn. Without taking out a calculator, what's the 15% tip for $30? what do I do to my 30 to get 10%?
Decimal.
So 5% is half that. So 15%. Everyone got what I did before I caught up to you? Okay, so tipping is one instance where estimation is very useful. If my restaurant bill was $21.87, then I wouldn't want to do even this shortcut with such a large number of decimal points, but I could just say pretend it's 22 and find a tip on 22 bucks. So that's what those are to. Another example is when we have things going on sale. Oops. No. So a book normally costs 12 bucks. It's on sale, 20% off. So what's the 20%? So how much is 10% of 12?
$1.20.
$1.20, exclude the decimal points. So times 2 to get to 20%,
40.
40. So potentially handy. Questions on this? Should we keep going to different stuff? Okay, before we're done, then all of these problems told us a percentage. We were trying to find 20% of this or 15% of that. You can make an English sentence that uses the words of and percent that's asking about the percentage. That's the answer instead of what someone gave you. We don't multiply then. So if someone says in a tank of 8 fish or 10 fish, 8 are guppies, what percent of the fish are guppies? We're not doing this kind of problem yet. This one is asking the percent, asking for the percent. That's something different. So heads up on it. Someone's learning to annotate on my thing. Okay, ready for percent change? We're almost done. I know it's Monday and hard and almost lunchtime. So let's talk about finding the percent. Unsurprisingly, we're doing things backwards. So if going forwards was multiplying, what do you think going backwards will be doing?
Division.
Division. So a candy bar normally costs 75 cents. It's on sale for 15 cents off. What's the percent? So we're going to have a formula about this. Well, let's think about it before I give away the formula. Am I doing 75 divided by 15 or 15 divided by 75? Which makes more sense? Why does one make more sense?
I think I'd rather do 75 divided by 15.
So if I do that, then I get 5. If I do this one, then I'm getting 0.2.
Oh, that's what we want, huh? We want the percent.
How do you know?
I don't know. I'm just guessing because there's a decimal.
Yeah, so you've been well trained. The past 3 weeks haven't been a waste. When you see this decimal, you're also thinking that this is 20%. Right, we're using RipWow. So this is a percent in disguise. If I tried to make 5 a percent, I could, and I would get 500%.
Yeah, that's ridiculous.
That's ridiculous. It's not a 500% off sale. I'm not quite sure what that would be. So we can't get a nice answer like 5 and just slam a percent sign on. That changes the number. So we have to take something that looks a little not as nice, but then we have a legitimate way to make a percentage out of it. Okay, so how do we remember this? The percent change formula is we take the change and we divide by the original. So in this case, we had the change was the 15 and the original was the 75. So that worked. That one was the wrong one. My smiley face doesn't look terribly happy, does it? There we go. Okay. Everyone okay with that? So change divided by original, and that's certainly worth memorizing. We will use that again and again and again. So when we see this sort of problem, then we don't have to think too much, just percent change. Which is the change? Careful, trick question, no. The original is certainly 80 cents. We started at 80 cents. We went down to a price of 60 cents. Oops, make that look not like an 86. Whoops, and I put dollars. I'm messing up all sorts of ways, aren't I? Okay, so now that I draw it that way, what's our change?
20 cents.
20 cents. It's not in the original problem. This could have instead asked me, what is the percent of the new price? And then I would have done 60 divided by 80. But it didn't. It asked me what's the percent of the decrease, so I had to find the decrease. So just a heads up on that one. The new amount, the change amount has to match what they're actually asking you for. We'll get to other problems later where they ask you what's the new price, but for now we're just doing the changes, which might be secret until you find them. And with that, I think we're ready to stop. So there's some more to practice on. We'll talk about them more later. And then here's your nice summary thing. So we'll do a little bit more when I see you Wednesday, and then we'll get to this and your brain can rest. But yes, that's a nice kind of conclusion, but I don't want to try and push us in 5 minutes and get to there. Just a little bit more to do. Okay, any last questions or things?
What about the midterm stuff?
The midterm stuff, that was, if you wanted to, you could go here to playgrounds, go down to topic tests and say, I'm ready to do a shape-shifting test. We've finished all of shape-shifting. I've turned in my homework. If you take one of these at home and do well, then okay, you've had some good practice. You're ready to try one for real. Let me know, send me an email or tell me right now, and then I will print one up where I will have the answers and you don't, and send that to you by email, and then you get back to me. And then that can be your take-home midterm. Does that make sense?
Didn't you already send one an email?
I think I did already, so I haven't gotten any back. I can send another one if people want.
I printed off that one.
Okay, so no rush. When you're ready for it, try that one. And if
I
you
think I
want to,
missed that one. That's what I was asking you this morning. Like I thought, because I've been looking for it and I can't
So
find it
resend
in my
it?
emails.
okay,
Resend,
so
yeah.
so I'll
Please.
resend it. Official.
And so then when we feel comfortable with this, we send you this one? Or you send us another one that we do a different, and then how do we get it to you?
I thought did I put it up? Yeah, I put a link to it here in the topic midterm. Oh, we were going to do group work today, weren't we? I totally forgot because the weekend was crazy. I'm sorry. Do you want to work on one of these next class? We don't have to keep pushing ahead with mad science. Would that be a boring thing to do for 2 hours, or do you want to just spend a lot of time going through this one by one? I'm sorry I changed things on everyone.
I actually like going through stuff.
Should we save this for a study session?
That'd be good.
Maybe Wednesday or Friday? Just have lots of shape-shifting work done together. Okay, so I will take where it says week 4 Monday and change that to study session, and the link is here, and I will also send this out, this link in the email, so you don't have to go to this page. Sound good?
So is the study session today or Wednesday?
We have one today, but since no one has really seemed interested in the midterm yet, I'm hesitant to say that's what we should officially do today. I think we'll have enough questions on the new stuff we just did. But if people want to, we can.
When is the midterm due?
Whenever you get to it. No one cares how much math you know in week 4. So,
Okay.
and you don't have to do a midterm. If you look carefully at the achievements, then scoring well on a midterm means you don't have to do as well on the final, because you can have your star here with the do well on a midterm instead of here with the do very well on the final. There's also a no calculator test that gives you another way to not have to do so well on the final. But for most people, they hate the no calculator test. They'd much rather do a take-home midterm. Okay, other questions?
Thank you, David. That was really helpful.
You're welcome. Thank you all for being willing to jump through lots of hoops. I want you to leave here in the end of Math 20 feeling like you're very good at math, and you will be. You'll be able to do things that most people can't do. So you will not be allowed to say at the end of this term you're bad at math, because that would be insulting to most people. But it is a lot of work, so thank you for being willing to do lots of different kinds of things. Okay, see you in a study session in 10 minutes if you want, or if your brain is tired and it's lunchtime, have a good day.
Yeah.
Thanks, David.
Thank you.